Welcome back. Today is day 2 of our Intros to Circles unit. In today's lesson, we'll be using GeoGebra to investigate the relationships for central and inscribed angles. Teachers, you can find the link to this activity in the description below. Let's have some fun with GeoGebra. Alright, so in this first little app here, we're supposed to move C and D around, so that means I can drag and drop. I think I can drag and drop this. Let's see. Let me let it load. It's on my iPad. Oh, okay, so there we go. So I can drag and drop this around. So again, I can make this arc smaller, and look at the arc is measure of arc CD. We can make it bigger, so arc is bigger, arc is smaller, but what happens when I just keep moving it? Oh, wait, hold on, something's happening here. So there's red, there's blue, and I think I saw hold on, there's another color in there. And right there, oh, there we go, okay. There we go, finally, okay. So here's what I noticed. When the arc is, let me see, if 180 degrees, we get a green arc. Anything smaller than 180 degrees is still red, so this is a red arc, okay. 180 is green, and then if it gets bigger, it looks like it becomes blue. All right, perfect. So let's summarize. If you can go down below and write me an answer, what did you notice? Really, that's what you're supposed to notice. What were we supposed to learn from this little activity? So from that little applet. So a minor arc, basically a small arc. Let's put a small arc on here. So a small arc, like this one here, that's a minor arc. Let's call that AB. All right, a major arc is going to be really just a large arc. Okay, so it's a large arc like this one way over here. And I'm going to call this A, and then I'm going to say this is B, and I'm going to say this is C. Okay, and I'll tell you why in a second. I'll explain that. All right, and then so that's a major arc, and then a semicircle. Well, that was just half of a circle, so or half of the circle. So let me just draw from here all the way there. So I'm just drawing exactly half, and let me put 3 points over here. All right, and let's call this one A, B, C. All right. Now, when you're naming these, this one, I would just name this one arc. Remember, when we talk about arcs, we're going to draw the arc symbol, so this would be arc AB. All right, and now arc AB, what's the difference between a major arc and a minor arc? Well, the difference is that the measure, again, of arc AB has to be less than 180 degrees, or less than half of the circle. So anything that's less than half of the circle is just a minor arc. All right, well then that means for this next one, and I want you to notice something, so let me write something down. This next one will obviously be greater than 180 degrees. All right, but again, for this one, we use 3 points. Now think about it. Why would we use 3 points this time and only 2 the other? Well, the answer is simple. Because we wouldn't know, if we only use 2 points, I wouldn't know what direction you're talking about. I wouldn't know if you said, for instance, in this problem, if you said arc AC and our convention was only 2 points, I wouldn't know if you meant this way in this blue part or if you meant the red arc. Okay, so anytime we're going to be using a major arc, we're going to use 3 letters. That way I know exactly which way you're talking about. So we're going to say, in this problem here, arc ABC, and that's a major arc. And that's because the measure of arc ABC is greater than 180 degrees. So it's more than half. So we have less than halfway, we have more than halfway, and then semicircle. Guess what? And same thing with this one. You're going to need 3 letters to name this arc. So just follow the path and find 3 letters in a row. So A to B to C. And that's because this arc is gonna, ABC is equal to 180 degrees. Perfect. So that's it, simple. Minor arcs is when the arc is smaller than 180, major arcs when it's larger, and if it's exactly, then it's called a semicircle. So let's try this one. It says find the measure of each 6 colored arcs. So we have 6 colored arcs. I have like an orange, a red, a green, a blue, and a purple, I think. Do this by creating a radius from each endpoint of the arc. Okay, so for instance, let me do this, and you're going to use a segment tool. So you have a list of tools here. You can scroll through here, and again, teachers, you can create a class with your students, and they can all get this assignment, and you can see what they're doing. So again, check that out too. The code will be in the link in the description, but I'm looking for a segment tool. So somewhere in here, there's a segment tool, and there it is right there. There's a segment tool. So I'm going to use that to create a segment. So I'm going to create a segment from D to A, and I can just do that by connecting D to A. And then also I'm going to create this one. So I'm going to create a segment from C to A, and there we go. So I made an angle. That's what the first part wants us to do. And you're going to do that for every single one. So there's a central angle. And we're going to do it for each colored arc. But let's go to step 2. So once we know how to do 1, we can do all the rest. Find the measure of the corresponding central angle. So now we're going to find the measure of the central angle. So that means there's going to be an angle tool in here, something that finds the measure for me. So let's find the angle tool. And there it is. So you see right there, it says measure, and then it says angle. So if I click on that, now that should allow me to, I believe, let's try it. So that should allow me to take a measure of this. Now, GeoGebra is kind of weird. So when you click on this, I think you have to go in a clockwise order. So for when I do this, you can do it 2 different ways. One is you can click on the side link. So I can click on segment AC and then click on segment AD, and it'll type the angle in there. So my angle will be right in there, 61.059, ... Okay, so I can type the angle in there. Or another way, and again, you'll use this tool a lot, the back arrow. So hit the back arrow to go backwards, or you can use 3 points. So I can go to C, then I can click on A, and then I click on D, and that will find the angle. Okay, so when you're doing this and you want to move things around, always go back to the move before you click anything else. So make sure you go back to it, and now I can see, okay, this angle right here is 61 point something, I'm going to probably I'll probably adjust it by the time you guys do this one, so that way it's rounded. It won't be with all those decimals, all right? But then you'll repeat the process for the rest of them. So I want to find the measure of each central angle that goes with each arc of this problem. All right, and then you have a couple questions to answer also. This problem. For this one, we're going to look at a different relationship. So this one says find the measure of arc CD. Well, remember what we learned the other day? You could find that measure just by finding. Let me click on. Actually, I need to click on the right tool. I don't even have a tool loaded. Click on the segment. Let me find the segment tool. And let me just rewind this one time. There we go. I deleted the point on accident. I'm going to click on the segment tool. Let me make a central angle, because if I can find the central angle, I'll know what the measure of that arc is. All right, so let me find the measure of that angle. Measure right there. There it is. Measure. Let's find this. And again, I'm going to go D, then A, then C. If it gives you the wrong angle, if it gives you like the exterior angle of what you're looking for, oh, I like this too. So the measure of this angle is 42 degrees. And on this one, as you can see, we can actually drag these points around too to kind of see it. All right, so that's step 1. But step 2, now what I want you to do is to create the following inscribed angles, and they're labeled right there. So angle CED. So you're going to do the same thing, but you're going to create a lot of angles and find the measure. So this isn't going to be too bad. So we're going to have to go back to the segment tool. And let's create that first one, CED, so you know what we're talking about. So CE, and then I need this one, D to E. And again, if you wanted to, you can also change somewhere in here. I think you could change the color so it looks nice. But But now here's my angle that I'm talking about. And then you're going to find the measure of the angle. So once we're done, I want you to find the measure of that angle and all the other ones. All right, this one might get a little busy. You might want to blow your full screen up on this one so that way you can see everything. But again, once you're done, you have a few questions to answer, and there's a relationship you're trying to figure out. So make a conjecture below about the inscribed angles and central angles. So by the time you're done with this, you should be like, oh, I noticed something. And the cool thing is you can also move these around and see if anything changes. Remember, see what I just did? I clicked while I'm not in pen mode. You should make sure you go back to move before you try to move things around, okay? So it'll be cool once you're done to move these around and just check out what happens when you do that. Check out what happens to your number values. All right, so we see the central angles. Let me show you one more thing, just in case you want to see something else. This show or hide object. So this one right here, this show or hide object's really good if you want to hide things. Like say I don't want to see that central angle anymore. I'm just going to click it away, just get rid of it and the angle. I don't want to see those anymore. I'll hide those, and now they're gone. So that was like, just pretend like it was bugging me, so I'm going to hide them so I don't have to see them anymore. So now I can see clearly there's an inscribed angle. That's the angle, inscribed angle I was talking about from beginning one. So angle CED, there it is. All right, good luck. Hopefully you find the relationship. This is the big idea. What were we supposed to learn in this little activity here? Let's sketch out a picture. So we have a picture. Let's say, okay, this is a circle. We have another circle over here. Let's draw a central angle in here. So let's label this central angle. That looks like this. Perfect. So there's a central angle. And on this one, I'm going to draw a inscribed angle. Okay. So that's what we have so far. We have, and let's give it some letters. Let's say this is AB, AB, and this is C, and this one is A, B, and C. Okay, two different diagrams. Hopefully we understand that. Maybe I should have changed letters. But so in words here, what were we supposed to learn here? We were supposed to learn that this arc here, so this arc, what do we notice? Was the same, the measure of this arc was the same as the measure of the central angle. All right, so let's write that out. Okay, probably could be a little more clear, but what we're trying to see is that the measure of this arc is the same as the measure of that central angle. Those will have the same values. All right, and another way in symbols, let's write it out in symbols. So what does that look like in symbols? So we can say the measure of arc AB will be equal to the measure of angle C. I'm just gonna name it one letter right now so it's nice and simple. So we should have something like in this diagram. And let me put some numbers in here. So what if we told you that this angle was 80 degrees? Well, then I know, I mean, the arc was 80 degrees. Well, then I would know that this angle here would be also 80 degrees. All right, so those should have to be the same. So 80 degrees, they both would be 80 degrees. Okay, so that's what we're looking for. That's what we're trying to learn in this activity. Now, for inscribed angles, the same thing didn't happen. It was a little bit different. All right, so let me just label this arc here. So this arc AB, it was not the same as angle C. So let's try to see what we had here. So hopefully you notice. I'm going to write it in. I'm going to write it a little backwards. That way we can kind of see what's there. The measure of the inscribed angle, that's an angle, sorry, that's a horrible angle, is 1/2 the measure of the arc. In a lot of books, they say the intercepted arc. They mean the arc that's between or subtended, okay? The arc that's between the 2 points. All right, but I'm just going to be short and simple with this one. So this one is going to say, now, what do we know on this one? I'm going to write the measure of angle C is equal to 1/2 the measure of arc AB. Okay, so let's see if we can figure this out. So what if I told you in this problem that this arc was 80 degrees? Then what can we conclude about the angle? Well, the angle is going to have to be half of it, so it's going to have to be 40. So let's see if this makes sense. So measure angle C is 40, which means that half of 80 should be 40, and that would work out. Okay, so again, that makes sense. That's what we're trying to learn. So central angles, just remember, the central angle is equal to the arc, and for inscribed angle, it's half of the arc. Okay, or if you think about it backwards, double the angle to get the arc.